Okay, so 12-6 we did Thursday and Friday of last week, but the level of difficulty is not really high enough. So we're doing a part 3, and we're going to start talking today. These are quadratics with no bx term still, but this is the level of difficulty we kind of left off on with Friday, and we need to increase the level of difficulty. So let's just remember how to do this. First, you are taking the square root of both sides. And I get 2x plus 1 equals plus or minus 9. And the plus or minus is really important because if you don't write the plus or minus, then you don't have the next step, which is to take the 2x plus 1 and split it into two equations. One where it equals positive 9, and another one where it equals negative 9. Okay, so now I've got two basic two-step equations, once with the positive, once with the negative. So I'll subtract 1 both sides and get 2x equals 8. Then divide both sides by 2 so that x equals 4. That's one of my solutions. Then I've got 2x plus 1 equals negative 9. So I can subtract 1, and I get 2x equals negative 10. Negative 9 minus 1, negative 10. Divide both sides by 2, and I get a negative 5. So my two solutions are positive 4 and negative 5. Okay, so what we're going to do now is take this kind of equation, but kick it up a notch. Okay, you can see here where I've still got that expression in parentheses being squared, but now I have it multiplying with the leading coefficient, and I have a constant. Okay, I want to say that anything with bx, there's no bx term in this quadratic. It looks like there is, but there isn't because it's really squared. Is the only type of quadratic where I don't want to set equal to 0. So I really want to make that clear. We're not setting equal to 0. These are the 4 steps that you have to do, at least check for in each problem. You may not have to do all of them, but these are the steps, and this is the order of the steps. So the first step says move the constant to the other side of the equal. There's lots of constants in here, but the one I'm specifically talking about is the minus 11. I want to move it over to here. My goal is to get this 2x minus 4 by itself. So I'll get the plus 11. It's going to change sides, so it's going to change signs, and it's going to go to the other side. So plus 11, plus 11. So that will cancel. And my net, I'll bring everything else down. All of this comes down. 181 plus 11 is 192. So my next step says divide both sides by the leading coefficient. It's terribly tempting to distribute right here, but I can't distribute because that's multiplication before I square. So even in order of operations, that's wrong. But I'm not doing either one of those things because I'm working backwards. I'm going to divide both sides by 3. Okay, divide both sides by 3. That cancels out those 3's, and I bring that down. And 192 divided by 3 is 64. The next step says square root both sides. So I will square root 64, and I will square root this expression. And I get 2x minus 4 equals plus or minus 8. Now this is kind of where we started off in the warm-up today. So this is the level of difficulty I've added, is right here in the beginning. Okay, so now I'm going to do 2x minus 4 equals a positive 8, and 2x minus 4 equals a negative 8. Move this down a little bit. All right, add 4 to both sides, and I get 2x equals 12. Then divide both sides by 2, and x equals 6. Then we'll do this other side. Again, I'm going to add 4 to both sides so that I get 2x equals negative 4. Then we'll divide both sides by 2, and x equals -2. So that makes those both my solutions. Now, this is, the only way I could make this harder is if 64 were not a perfect square that's simplified to 8. But the steps are there. This is all the steps that I could possibly have. I'm not necessarily going to see every single step in every problem, but I need to check through these to see which ones I end up getting. So let's do some homework examples next. Okay, so this is number 7 from the new homework packet that you picked up today. 1 through 6 are easy review ones. Okay, so this obviously doesn't look as hard as the problem we just did. It does not, we're not going to use all of these steps. Okay, so the first step says move the constant to the other side of the equal sign. Well, I have a constant right here, so that is a step I am going to do. Okay, so that means I'm going to add 7 to both sides. And I have n squared equals 92. Now, the second bullet says divide both sides by a leading coefficient. There's no coefficient in front of n squared, so there's nothing to divide by. I'm going to skip that step. The next step says take the square root of both sides. Well, we have to do that because there's a square there. So square root, square root. The directions also say that I have to answer in the form of a simplified root. So I took square root both sides. So 92 breaks down into root 4 and root 23. Remember, I'm going to 92 and I'm going to test out all my perfect squares to see which one the highest 192 can divide by. And turns out 4 is the only one that works. Okay, so square root of 4 is 2. So 2 root 23. The 23 comes down. And square root of 4 is 2. Don't forget your plus and minus. Then the last step says solve twice for positive and negative solutions. But here again, that's not a step I have to do this time because n, we're done. We know what n is. There's not n, it's not 2n plus 5 or something we have to solve for. We don't have to do all the steps. Okay? Let's look at number 8. Okay, so in number 8, let's see, the first step says move the constant to the other side of the equals. There is no constant. There's no plus or minus in number after the b squared or in front of it that's being added or subtracted. So there's no constant to move to the other side. That's a step I can skip. I have to check, but I can't, there's nothing to do. So then I'm going to go to my next step that says divide both sides by a leading coefficient. Well, there is a leading coefficient of -5. So that's the step I'm going to do next. Divide both sides by -45. Okay, so I get v squared equals 9. Okay, square root both sides. Okay, and I get v equals plus or minus 3. So the steps that we had to do was divide both sides by a leading coefficient. So we did that. And we had to take the square root of both sides. So we did that. Those are the only 2 steps we had to do in this one. Okay? Don't have to do them all. Just check to see if you have to do it, and if you don't, move on to the next thing. Okay, here's 13 and 14. Again, these are a little bit more complex. Let's read each step and see if we have to do it or not. It says move the constant to the other side of the equal sign. So over here I do see a constant, and I'm going to have to move it to the other side. So I will subtract 1. Remember, that's a positive 1, so I'm going to subtract 1. And I bring down -8k squared. -759 minus 1 is -760. Okay, so I've done that step. Let's color code this. Okay, I've moved the constant to the other side of the equal sign. All right, next it says divide both sides by a leading coefficient. Well, I have a leading coefficient right there of -8, so I'm going to divide by that. Okay, so we did do that step. Oh, whoops. Meant to do the highlighter tool. Then it says square root both sides. I also have to do that step. I have to square root both sides. You're always going to have to square root both sides because that's where we're at with these equations. They're all going to be a square root. Okay? And I get k equals plus or minus 9.75. That's a rounded answer. The directions for this section tell you to answer as a decimal. You can round to the nearest hundredth or tenth because the directions don't say either way. It says solve twice for positive and negative solutions. Well, k is already solved for, so we don't have that step to do. Okay. Now we're going to do number 14. Start back at the beginning of our list. Move the constant to the other side of the equals. Okay, so I've got a minus 6 here. I'm going to add 6 to get 16x squared equals 81. So the step I did was to move the constant to the other side of the equals. That's what we did right here. Then the next step says divide both sides by a leading coefficient. So it's dividing both sides by 16. And that's a step we had to do right there. Okay, the next step says square root both sides. Now, when I did this division, I got a 4-digit decimal. This is not rounded. This is the whole thing. Do not round at this point because when I do square root in this step, we're going to get a nicer square root. If you round this, you will get a not nice square root. So do not round. Square root both sides is what I did here. Okay. And I get an answer of x equals plus or minus 2.25. So we're not solving twice for positive and negative solutions because I've already isolated x. It's not in parentheses. Okay. So those are my solutions. Okay, here's a problem from the homework that we probably didn't talk about in class, but I want to make sure that you see it on the video, a little bonus. K squared plus 5 equals negative 4, okay? So again, I want to go for the constant first, so I will subtract 5, both sides, and I get K squared equals negative 9. Okay, when you get to the step where you're being asked to square root both sides, not before. When you get to the step where you're square rooting both sides, if you have a negative number as a radicand, then you have no real solution to this question. Okay, you cannot take the square root of a negative number. It's not negative 3, it's not positive 3, it's not plus or minus 3. If you're interested, the answer is actually 3i. K equals 3i. But that's not a topic for this chapter. All you need to know if you get to a negative square root is that there's no real solution to this question. Okay? All right. I hope you enjoyed your 2-hour delay. And remember that we have ELA state testing this week and kind of a crazy schedule Tuesday, Wednesday, Thursday, and next week Wednesday, Thursday, Friday. Have a great day, and I'll talk to you later.